The reason why we wanted to do this is to solve an extreme problem. And that extreme problem, a lot of people misunderstood to be easy. And in fact, it is the ultimate extreme computing problem, and it's called inference.
I mean, it's fairly simple. It's all about speed, right? It's all about speed versus quality.
We call it Agentic AI. Agentic AI basically means that you have an AI that has agency.
Agentic AI is all about inference, right? Now you have the models, now you have the trained up models and thousands of choices. Now it needs to go into the inference space.
It caused us to decide to go all in on building self-driving cars.
I think for the general public, their first experience of physical AI is going to be autonomous robo-taxis.
What's amazing is this is completely liquid cooled, and by liquid cooling it, we can compress all of these compute nodes into one rack.
You need to scale up first before you scale out. And scaling up means you need to make the computers itself faster.
So, hello to Thomas Odenwald, back once again, Thomas. And yeah, I invited you on to help review Jensen Huang's just amazing keynote at GTC. Jensen, I believe, when it comes to AI, is someone who needs to be listened to. He called this thing way back in the early days. I mean, in the 90s, him and his team came up with the ideas of parallel processing on his GPUs, and then they had the vision around AI, and that's why they're the leaders in it. So I've invited you on today because what I've done is Jensen's talked. For anybody who hasn't seen it, it's like nearly 2.5 hours long. So we want to condense right down. So I've taken some short clips that will, I think, be the most relevant for our audience. So the ones focused on enterprise, use of enterprise AI, right? So what I thought we'd do, Thomas, if I play each clip, I'll come to you get your perspective. I'll give mine if I have any, and then we'll keep the pace up and get through these. And then anybody who missed Jensen's keynote or kind of forgot a little bit about it or whatever, then we'll cover the salient points for you. How does that sound, Thomas? And how are you doing today?
Yeah, hi Ben. Good to see you again. Yeah, I'm happy to do this. It's been a while since the keynote because everything moves very, very fast in AI. He called it the Super Bowl of AI. I think in the past he called it the Woodstock of AI. Now it's the Super Bowl, and I'm still amazed that they do it in San Jose because it's too big now for that town. And he mentioned that, right? He said this is
yeah.
we are outgrowing the facilities here. Who knows where they have to host it next? But yes, it was an amazing keynote. I tried to find some analyst who say something critical or anything negative about the keynote. Could not find anything. Yet the stock price is down more than 20% since the beginning of the year. But I think that has more to do with the macroeconomic happenings rather than what Nvidia is doing. But I think stockholders are still a bit disappointed about the volatility at this point.
Yeah, there's a few things called tariffs flying around at the moment, aren't there? So we all await Liberation Day, and then guess what? Just like with, I don't know, Brexit and everything, the market overreacts a little bit, and we're all okay in the end. But there's no one who doesn't think Jensen is an extreme innovator, and he has the crystal ball. He's demonstrated he has the crystal ball. So let's go into clip one. And this, again, I've taken part of Jensen's opening kind of intro, but I've even taken a chunk off that, right? And because I want to get straight into agentic AI. So let's hear from Jensen.
Last several years, the last couple, 2-3 years, major breakthrough happened. Fundamental advance in artificial intelligence. We call it agentic AI. Agentic AI basically means that you have an AI that has agency. It can perceive and understand the context of the circumstance. It can reason, very importantly, it can reason about how to answer or how to solve a problem, and it can plan in action. It can plan and take action. It can use tools because it now understands multimodality information. It can go to a website and look at the format of the website, words and videos, maybe even play a video. Learns from what it learns from that website, understands it, and come back and use that information, use that newfound knowledge to do its job. Agentic AI. At the foundation of agentic AI, of course, something that's very new, reasoning. And then, of course, the next wave is already happening. We're going to talk a lot about that today. Robotics, which has been enabled by physical AI. AI that understands the physical world. It understands things like friction and inertia, cause and effect, object permanence. When something goes around the corner, it doesn't mean it's disappeared from this universe. It's still there, just not seeable. And so that ability to understand the physical world, the three-dimensional world, is what's going to enable a new era of AI we call physical AI, and it's going to enable robotics. Each one of these phases, each one of these waves opens up new market opportunities for all of us.
So there we go, Thomas. Clip number one. That's Jensen on outlining that roadmap. He's somewhat ahead of the curve for most B2B enterprise, though, right at the moment. So what's your thoughts, Thomas?
Yeah, so a couple of things here. I think they made a big deal about his keynote is completely, totally unscripted. I'm still not sure if this is a marketing pitch or if this is really unscripted, because it's so smooth how the slides and the videos come up during the keynote. I cannot even imagine that this is unscripted. But anyway, be it that way. It doesn't really matter. The way he set that up, and he talked in the entire keynote that the overarching themes were reasoning, agentic AI, photonics, and then last but not least, he goes into robotics. And I like the way he basically, from a historical perspective, he built it up, starting with perception AI, which started 10 years ago. That includes speech recognition and everything else. And then it goes into generative AI, and then it goes into agentic AI that he just mentioned. And then later on, he comes into the physical AI world. And he spends quite a lot of time in the physical AI world because I think he likes robotics, and it seems to be coming very, very fast. The notes I made is on when it comes to agentic AI, and he talked at length about reasoning and the importance of reasoning, which is I have not heard that in that depth from him. And we know that reasoning with the latest OpenAI models, the latest DeepSeek models, is coming and is very important. So he spent quite a lot of time on the reasoning and on the agentic AI, and we talked about that in our first podcast, where I made the statement that I think 2025 is the year of inference, and I still believe agentic AI is all about inference. Right now, you have the models, now you have the trained up models and thousands of choices. Now it needs to go into the inference space, and hopefully the investments, the millions of dollars of investments come to fruition with all the different vendors and all the different companies out there. What are your thoughts on you heard on that?
I think you did call it when we first spoke about inference, and I think just talking about the trade kind of wars and the tariffs and just what I've been listening to about the US's view on this move from training to inference. The US want all the training to happen in the US and to be controlled by them, but they accept, of course, that inferencing is going to go on globally. Wherever your AI is running, it's going to be inferencing. So and the physical AI, and we've got some examples on that, which the next clip is about autonomous vehicles, which are, after all, just going to be robots on wheels, aren't they? And that, when you hear physical AI, that is the AI inferencing. So it's going it for sure fast in that direction, but how easy it is to adopt that in your enterprise as we've said before, is going to be the tricky part. But let's keep the pace up. We'll go on to inferencing in autonomous vehicles.
Well, AI is going to go into every industry. That's just one. One of the earliest industries that AI went into was autonomous vehicles. The moment I saw AlexNet, and we've been working on computer vision for a long time, the moment I saw AlexNet was such an inspiring moment, such an exciting moment. It caused us to decide to go all in on building self-driving cars. So we've been working on self-driving cars now for over a decade. We build technology that almost every single self-driving car company uses. It could be either in the data center. For example, Tesla uses lots of Nvidia GPUs in the data center. It could be in the data center or the car. Waymo and Wave uses Nvidia computers in data centers as well as the car. It could be just in the car. It's very rare, but sometimes it's just in the car. Or they use all of our software in addition. We work with the car industry however the car industry would like us to work with them. We build all three computers, the training computer, the simulation computer, and the robotics computer, the self-driving car computer, all the software stack that sits on top of it, models and algorithms, just as we do with all of the other industries that I've demonstrated. And so today, I'm super excited to announce that GM has selected Nvidia to partner with them to build their future self-driving car fleet. The time for autonomous vehicles has arrived, and we're looking forward to building with GM AI in all three areas. AI for manufacturing, so they can revolutionize the way they manufacture. AI for enterprise, so they can revolutionize the way they work, design cars and simulate cars, and then also AI for in the car. So AI infrastructure for GM, partnering with GM, and building with GM their AI. So I'm super excited about that.
So let's pause that there. And that is physical AI, isn't it? I think for the general public, their first experience of physical AI is going to be autonomous robo-taxis. I know obviously we've had Waymo for a while, but that's using LiDAR technologies. When Nvidia are involved in this, it's going to be using the GPUs to be inferencing, and that is the brain of the robot. In this case, it's a robot on wheels. The car, Tesla's new pilot for their robotaxi, I think, is scheduled for June of this year. And again, they're using 8 cameras on the car, and the robot is driving the car, right? The AI is driving the car. So physical. This is the first manifestation of physical AI before we get to the humanoids. What's your thoughts, Thomas?
Yeah, 2 thoughts on that one. First of all, I talked to my mom yesterday, and she's 80 years old, and I explained to her that Waymo is now available where I live in Redwood City. So they came down from San Francisco, where they started a year ago. Now it's available in the peninsula as well. And it's still, I mean, it even amazes me, but of course, for my mom, that was too much. She didn't quite get what I'm saying, but it is absolutely stunning. I mean, I did not expect that to happen in my lifetime. Bit surprised that he singled out General Motors in that announcement, because all the other car manufacturers are big Nvidia customers, including Tesla, of course. So I tried to dig up a little bit more information what the GM announcement really means and how it distinguishes from Nvidia's partnerships with others, because throughout the keynote, Jensen was very particular about mentioning as many partners as possible and always agnostic, right, to all these different partners. So a bit surprised about the GM announcement. Couldn't find any more information beyond the announcement itself yet, but I'm sure it has some significance.
Yeah, look, I think, and I'll play the next clip, which is how their technology is training the vehicles, using essentially synthetic, real world and synthetic training data. it made me think when I saw GM, I was like, what? It made me think, well, who's the car company that's furthest behind on AI and desperately needing a solution? Well, maybe it's GM. But let's play the next clip, and we'll see the car and the vision, I guess, of Nvidia's technologies for these different cars.
All of you have seen cars drive by themselves. The Waymo robo-taxis are incredible. But we made a video to share with you some of the technology we use to solve the problems of data and training and diversity so that we could use the magic of AI to go create AI. Let's take a look.
Nvidia is accelerating AI development for AVs with Omniverse and Cosmos. Cosmos prediction and reasoning capabilities support AI-first AV systems that are end-to-end trainable with new methods of development. Model distillation, closed-loop training, and synthetic data generation. First, model distillation. Adapted as a policy model, Cosmos's driving knowledge transfers from a slower, intelligent teacher to a smaller, faster student inferenced in the car. The teacher's policy model demonstrates the optimal trajectory, followed by the student model learning through iterations, until it performs at nearly the same level as the teacher. The distillation process bootstraps a policy model, but complex scenarios require further tuning. Closed-loop training enables fine-tuning of policy models. Log data is turned into 3D scenes for driving closed-loop in physics-based simulation using Omniverse neural reconstruction. Variations of these scenes are created to test a model's trajectory generation capabilities. Cosmos Behavior Evaluator can then score the generated driving behavior to measure model performance. Newly generated scenarios and their evaluation create a large dataset for closed-loop training, helping AVs navigate complex scenarios more robustly. Last, 3D synthetic data generation enhances AVs' adaptability to diverse environments. From log data, Omniverse builds detailed 4D driving environments by fusing maps and images, and generates a digital twin of the real world, including segmentation, to guide Cosmos by classifying each pixel. Cosmos then scales the training data by generating accurate and diverse scenarios, closing the sim-to-real gap. Omniverse and Cosmos enable AVs to learn, adapt, and drive intelligently, advancing safer mobility.
All right, let's stop at that. Yeah, so as I'm watching that, Thomas, I'm thinking, yeah, safer mobility, and how happy are you going to be walking down the street and the driverless cars are driving past you kind of less than 2 meters away. So, but for anyone just listening and not watching on video, they're just showing their Omniverse and Cosmos systems, which are what you'd use if you had a factory environment with robots working in it, right? It's the same product set. It's just applied to a different use case, in this case, autonomous vehicles. But it's just showing that taking real world data and then just creating instance of different permutations of that real world data, and essentially then getting into creating synthetic data. So it's trained on every possible circumstance. Part of something in my brain, Thomas, says, yeah, but that's still not, I'd still prefer a human behind the wheel. But actually, I guess the stats will speak for themselves, right? And I think Tesla's got 6 billion miles, or is it billion miles now on their full self-drive systems? It's a lot of data, right?
Yeah, I think a little bit differently, Ben. I trust the self-driving car more than any young driver being on her cell phone or his cell phone while driving. or being drunk. I mean, that is to me much more scary than a self-driving car. And I don't know, there are some funny videos on YouTube where people walk around with stop signs on their shirts in San Francisco just to spook self-driving cars.
Oh, wow.
It becomes a bit of a joke now because apparently they stop then when they see the stop sign, somebody walking on the sidewalk with that shirt on. But I think that the usage of GPUs goes beyond self-driving cars as well. I don't know if that was mentioned in the keynote, but I think I heard somewhere that every modern car has GPUs in it, no matter if it's self-driving or not, no matter if electric or not electric. But nowadays, all our modern cars are driving computers with GPUs in it. It doesn't have to be an Nvidia GPU. I think some of the car manufacturers have different kind of GPUs in them. But they all have GPUs because there's always a massive data management happening inside the car, independent of the self-driving. Of course, with self-driving, that's even more pronounced. But he made, later on in the keynote, one of the profound statements that was made either by him or by the voice on the video, which was always him, by the way, on all the videos, where he says, everything, I wrote it down, everything that moves in the future will be autonomous. And I had to think about that. I had to let that sink, right? I'm like, what are we talking about? And I think his point is everything in the future will be kind of self-driving or self-regulating based on a computer chip. No matter if it's your lawnmower or your car or whatever else that moves, maybe with the exception of mammals and human beings.
Yeah, and Jensen's talking about it in very simple terms, isn't he? That we can all understand. Is he's saying, okay, you have 3 computers, depending on what the use case is, and the digital twin will be created by Omniverse, the application Omniverse, and then we'll scale your synthetic training data using Cosmos, and that's how you'll realize that future that you just talked about, Thomas.
He went one step further. Yeah, I mean, he went even one step further beyond Omniverse. He talked later in the keynote about the twin data center that is needed for that kind of reinforcement learning, right? So his point was everybody in the future needs 2 data centers, one just for the data and that kind of synthetic data generation, and then another data center that is responsible for your product. And I thought that was a stunning vision that he threw out there, that everybody in the future needs a twin data center just to manage the data.
It's a good segue because we are now moving swiftly on from autonomous vehicles and into the data center. So let's hear Thomas, I think, opening that section about data center. Let's go.
Scaling up is incredibly hard. There is no simple answer for it. You're not going to scale it up. You're not going to scale it out like Hadoop. Take a whole bunch of commodity computers, hook it up into a large network, and do in-storage computing using Hadoop. Hadoop was a revolutionary idea, as we know. It enabled hyperscale data centers to solve problems of gigantic sizes and using off-the-shelf computers. However, the problem we're trying to solve is so complex that scaling in that way would have simply cost way too much power, way too much energy. It would have never, deep learning would have never happened. And so the thing that we had to do was scale up first. Well, this is the way we scaled up. I'm not going to lift this. This is 70 pounds. This is the last generation system architecture. Is called HGX. This revolutionized computing as we know it. This revolutionized artificial intelligence. This is 8 GPUs. Each one of them is kind of like this. Okay, this is 2 GPUs, 2 Blackwell GPUs in one Blackwell package. 2 Blackwell GPUs in one Blackwell package. And there are 8 of these underneath this. Okay? And this connects into what we call NVLink 8. This then connects to a CPU shelf like that. So there's dual CPUs, and that sits on top. And we connect it over PCI Express, and then many of these get connected with InfiniBand, which turns into what is an AI supercomputer. This is the way it was in the past. This is how we started. Well, this is as far as we scaled up before we scaled out. But we wanted to scale up even further. And I told you that Ranger took this system and scaled it up by another factor of 4. And so we had NVLink 32, but the system was way too large. And so we had to do something quite remarkable, re-engineer how NVLink worked and how scale-up worked. And so the first thing that we did was we said, listen, the NVLink switches are in this system embedded on the motherboard. We need to disaggregate the NVLink system and take it out. So this is the NVLink system. Okay, this is an NVLink switch. This is the highest performance switch the world's ever made. And this makes it possible for every GPU to talk to every GPU at exactly the same time at full bandwidth. Okay, so this is the NVLink switch. We disaggregated it, we took it out, and we put it in the center of the chassis. So there are 18 of these switches in 9 different racks, 9 different switch trays, we call them. And then the switches are disaggregated. The compute is now sitting in here. This is equivalent to these 2 things in compute. What's amazing is this is completely liquid cooled. And by liquid cooling it, we can compress all of these compute nodes into one rack.
So let's pause there because it's quite a long clip, but I wanted to give the listeners the context of the changes that have been made to this technology, and I'll get your thoughts on it, Thomas. But I'd like you to touch on liquid cooled. That's a really big change that's allowed them to redesign that system, and they, of course, I've got a clip in a couple of clips' time about energy consumption being the new limiting factor. What's your perspective on what Jensen was saying there, Thomas?
I like how he started off with taking the Hadoop example, because that was at that time a breakthrough, but based on off-the-shelf computers who could not scale up, so you could only scale out. Now I had to listen to that section of Jensen's keynote twice, because he mixed up a bit scale up and scale up and scale out a few times, and it was a bit confusing. But what he means is basically you need to scale up first before you scale out, and scaling up means you need to make the computers itself faster, and that's what this is all about: liquid cooling, NVLink, photonics. Bigger, and we come to that, right? More powerful GPUs. This is all about scaling up the computer before you scale out with an array of computers. The liquid cooling is definitely one part of that, and I know for a fact that some of the companies, without mentioning the names, in the Middle East are experimenting with data centers underwater, which is different than liquid cooling, right? Liquid cooling is cooling the machine itself, but entire data centers that are submerged now, and in order to cool down the heat, I also think he missed a little bit the opportunity on talking about where should all this energy coming from, right? I mean, what about sustainability? Where are we going with this? Who can satisfy that hunger for energy? Because we know that Microsoft now is buying 3 Mile Island, a nuclear plant, in order to power their AI. Where should all that coming from? And he deliberately stayed away from that. Yes, he talked about energy a little bit, but I wish he would have dug a little bit deeper into that part of the problem.
Yeah. It's obvious. He talks about it being a limiting factor, and trying to. And I guess from their perspective, they're just trying to make this as energy efficient as they possibly can in terms of the technology. and then where's each country going to find this energy? But let's some great points there. Let's move on. Next clip, and we're staying with the data center here, and Jensen's going to go into the move from Grace Hopper into Blackwell. Let's listen to him.
The reason why we wanted to do this is to solve an extreme problem. And that extreme problem, a lot of people misunderstood to be easy. And in fact, it is the ultimate extreme computing problem, and it's called inference. And the reason for that is very simple. Inference is token generation by a factory. And a factory is revenue and profit generating, or lack of. And so this factory has to be built with extreme efficiency, with extreme performance, because everything about this factory directly affects your quality of service, your revenues, and your profitability. Let me show you how to read this chart, because I want to come back to this a few more times. Basically, you have two axes. On the x-axis is the tokens per second. Whenever you put a prompt into ChatGPT, what comes out is tokens. Those tokens are reformulated into words. It's more than a token per word, okay? And they'll tokenize things like THE could be used for the, it could be used for them, it could be used for theory, it could be used for theatrics, it could be used for all kinds of, okay? And so THE is an example of a token. They reformulate these tokens to turn into words. Well, we've already established that if you want your AI to be smarter, you want to generate a whole bunch of tokens. Those tokens are reasoning tokens, consistency checking tokens, coming up with a whole bunch of ideas so they can select the best of those ideas tokens. And so those tokens, it might be second guessing itself. It might be, is this the best work you could do? And so it talks to itself just like we talk to ourselves. And so the more tokens you generate, the smarter your AI. But if you take too long to answer a question, the customer's not going to come back. This is no different than web search. There is a real limit to how long it can take before it comes back with a smart answer. And so you have these two dimensions that you're fighting against. You're trying to generate a whole bunch of tokens, but you're trying to do it as quickly as possible. Therefore, your token rate matters. So you want your tokens per second for that one user to be as fast as possible.
All right, I mean, you got to remember his audience here. It's not designed for the general public, is it, Thomas? He's got a lot of developers in the room. I'm not even playing the clips when he's talking about CUDA libraries and he's talking to developers. It's just too straight over the top of your head. So, but he is mentioning tokens and he is mentioning some concepts there that we can all relate to. But Thomas, decipher that for us if you can.
I mean, it's fairly simple. It's all about speed, right? It's all about speed versus quality. The analogy to what he said, web search, right? You want to have the best results, but at the same time, it's a time crunch. You don't want to wait too long because then you walk away. Same principle here. Speed versus quality, and when he talks later on about the roadmap and what's coming in the next years. And now they tap the roadmap by year, not every 2 years any longer. It's quite amazing what he has in his roadmap and how they speed up in the upcoming years if that's coming true.
Yeah, that's right. So let's go to the next clip. I think we're staying with the same theme. Let's add this clip to our
LLMs capture foundational knowledge, while reasoning models help solve complex problems with thinking tokens. Here, a prompt asks to seat people around a wedding table while adhering to constraints like traditions, photogenic angles, and feuding family members. Traditional LLM answers quickly with under 500 tokens. It makes mistakes in seating the guests, while the reasoning model thinks with over 8,000 tokens to come up with the correct answer. It takes a pastor to keep the peace.
So you've got
Okay. As all of you know, if you have a wedding party of 300 and you're trying to find the optimal seating for everyone, that's a problem that only AI can solve or a mother-in-law can solve.
All right, I thought I wouldn't talk over Jensen's joke there. He obviously worked hard on that one. But look, really interesting that, wasn't it? Looking at how a reasoning model's using 8,000 tokens to answer the question versus the traditional LLM using 400. And of course, if you're an enterprise customer paying per token, you're also interested in that dynamic. But and you can see when you use DeepSeek R1 or ChatGPT's reasoning model, it's obvious. It's explaining its chain of thought, and it's so obvious that it's using dramatically more tokens than the language model.
Yeah. My thoughts went somewhat completely different when I saw that. Right, not to my wedding problems, but he mentioned at the very beginning, and I noted it down, and he said the retrieval computing model that we all know, that's the transactional model that everybody is still using, will be replaced by the generative retrieval model. And when I see this example, I'm wondering now, and I think we touched on that in the previous podcast, is what's the future of a CRM system or an ERP system, right? A customer relationship management. Do you still need those? Do you still need in the future customer? I'm a little bit. How do I say? I want to be a bit out there. Do you need a transactional customer relationship management system in the future, or can a generative retrieval model can do that on the fly? You get some customer data in, and it instantly knows what to do with that, what the next steps. You don't need a customer relationship management system anymore. Look, I could be completely wrong, and I'm sure there's pushback on, but you have to have certain workflows, and they need to be pre-configured, yada, yada, yada. I slowly but surely believe that we're going into those areas now where we can replace these big systems with ad hoc AI systems.
Yeah, and that's a huge threat to as-a-service software models, isn't it? That does unseat that whole industry. And I guess if you're running an enterprise, you would be delighted to avoid your charge for Salesforce.com or Workday or whatever it might be.
Right.
But also, when we looked at the Klarna example, which turned out to be kind of slightly smoke and mirrors, but it is kind of where the industry is going. And then how do you achieve compliance if you don't have that, if you don't have those systems anymore? So, yeah, but I think you're right. I think eventually that's where this is gonna lead to, right?
I'm sure some people think we are discussing smoke and mirrors here, but honestly, it's a thought in my mind that for some reason doesn't go away at the moment. And I honestly believe we are onto something here.
Yeah, let's see. Let's see what happens. Let's move on to and like we said at the start of this whole keynote is a view to the future. It's not what's going to happen in 3 months, 6 months. It's a view to the future over the next few years. But you never know. We may get there faster than we think. But let's jump to the next clip, and I think we've got 3 more clips.
LLMs capture
Not that one. I just played it.
We are starting to build what we call the digital twin of every data center. Before you build a data center, you have to build a digital twin. Let's take a look at this. This is just incredibly beautiful.
The world is racing to build state-of-the-art, large-scale AI factories. Bringing up an AI gigafactory is an extraordinary feat of engineering, requiring tens of thousands of workers, from suppliers, architects, contractors, and engineers, to build, ship, and assemble nearly 5 billion components and over 200,000 miles of fiber, nearly the distance from the Earth to the Moon. The Nvidia Omniverse blueprint for AI factory digital twins enables us to design and optimize these AI factories long before physical construction starts. Here, Nvidia engineers use the blueprint to plan a 1 gigawatt AI factory, integrating 3D and layout data of the latest Nvidia DGX superpods and advanced power and cooling systems from Vertiv and Schneider Electric, and optimized topology from Nvidia Air, a framework for simulating network logic, layout, and protocols. This work is traditionally done in silos. The Omniverse blueprint lets our engineering teams work in parallel and collaboratively, letting us explore various configurations to maximizing TCO and power usage effectiveness. Nvidia uses Cadence Reality Digital Twin, accelerated by CUDA and Omniverse libraries, to simulate air and liquid cooling systems. And Schneider Electric with ETAP, an application to simulate power block efficiency and reliability. Real-time simulation lets us iterate and run large-scale what-if scenarios in seconds versus hours. We use the digital twin to communicate instructions to the large body of teams and suppliers, reducing execution errors and accelerating time to bring up. And when planning for retrofits or upgrades, we can easily test and simulate cost and downtime, ensuring a future-proof AI factory.
You mentioned that at the start, didn't you, Thomas, about these digital twin data centers? Do you know what? I never even thought about this concept, but it makes perfect bloody sense, doesn't it? That you would build a digital twin, and what do you think they're doing with this? What do you think the value is going to be for enterprise, Thomas?
Well, more data. So they need more data in order to run the show, and they need synthetic data, and synthetic data are based on historical data. So they have a whole data center now that creates additional synthetic data for reinforcement learning and these huge models that do the reasoning part. It all makes sense, and of course it's good for Nvidia because they sell even more GPUs and more software.
Yeah, and the other thing that they're saying is they're able to simulate power scenarios, weather scenarios, all different scenarios. And one of the things that Elon mentioned, because obviously they've bought that old Electrolux factory and turned it into a giant data center with all of this liquid cooled GPU technology within it. And he said one of the biggest challenges they had was power, not power consumption, just when they've got all of those GPUs running in parallel, just having a really smooth flow of power into their data center. And to be able to simulate that and understand when your AI models are reasoning at scale, to simulate different scenarios just seems like a really useful thing to be able to do, because the first thing you notice, or when I'm using the ChatGPT app, it goes offline. It will just suddenly say network error or whatever, and it will just go offline for maybe only a few minutes, but you notice it, and yeah, that's that. And they're one of the biggest companies in the world. What happens if you've got your own data center and it starts having some performance issues?
Yeah.
But
Ben, I want to point. I'm sorry to get a little bit offline here, but I want to point something more that I wrote down in the context of what he mentioned about the data center, because he didn't mention it in the keynote. He mentioned it in the press conference afterwards. And I found it stunning. That's why I wrote it down. So they predict Nvidia, or he predicts Nvidia's revenue in the year 2028 will be $1 trillion from data centers. $1 trillion in revenue. The biggest company in terms of revenue today is Walmart, with 680 million. So this is almost, it's almost twice as much as Walmart has today. And that's just data centers. That doesn't include all the other things that they are selling. And the interesting part was, this is reachable and it will be the biggest company in the world, no doubt about that, right? But it's reachable if they grow by 72% annually. Nvidia grew in terms of revenue 93% year over year. So it's absolutely achievable. But $1 trillion in revenue is something unheard of. So I found these numbers just stunning.
Yeah.
That's why I wrote them down. And that will result, it says here, it will result in a market cap of 12.5 trillion. Today it's only 3 trillion. And yet they have an over 50% profit margin. I mean, these numbers are just stunning by itself.
Yeah.
So yet the stock market is down, or the stock is down, but just looking at these numbers, it's just mind blowing what the predictions are for Nvidia.
Yeah, it is, isn't it? And let's take a look at our final clip. I'm trying to keep us around 45 minutes today, and this is clip 9 is the DGX launch. Let's listen to the DGX launch.
Next, thank you, Janine. The next one is also a brand new computer, one that the world's never had before. So we're announcing a whole new line of computers. This is a new personal computer, a new personal workstation. I know, it's crazy. Check this out. Grace Blackwell, liquid cooled. This is what a PC should look like. 20 petaflops. Unbelievable, 72 CPU cores, chip-to-chip interface, HBM memory, and just in case, some PCI Express slots for your GeForce. Okay, so this is called DGX Station. DGX Spark and DGX Station are going to be available by all of the OEMs. HP, Dell, Lenovo, Asus. It's going to be manufactured for data scientists and researchers all over the world. This is the computer of the age of AI. This is what computers should look like. And this is what computers will run in the future. And we have a whole lineup for enterprise now, from little tiny one to workstation ones, the server ones to supercomputer ones, and these will be available by all of our partners. We will also revolutionize the rest of the computing stack. Remember, computing has 3 pillars. There's computing, you're looking at it. There's networking, as I mentioned earlier, Spectrum X going to the world's enterprise, an AI network. And the third is storage. Storage has to be completely reinvented. Rather than a retrieval-based storage system, it's going to be a semantics-based retrieval system, a semantics-based storage system. And so the storage system has to be continuously embedding information in the background, taking raw data, embedding it into knowledge, and then later when you access it, you don't retrieve it, you just talk to it. You ask it questions, you give it problems. And one of the examples, I wish we had a video of it, but Aaron at Box even put one up in the cloud, worked with us to put it up in the cloud. And it's basically, a super smart storage system. And in the future, you're going to have something like that in every single enterprise. That is the enterprise storage of the future. And we're working with the entire storage industry, really fantastic partners, DDN and Dell and HP Enterprise and Hitachi and IBM and NetApp and Nutanix and Pure Storage and VAST and Weka. Basically, the entire world storage industry will be offering this stack. For the very first time, your storage system will be GPU accelerated.
So a couple of announcements there, Thomas, DGX and then GPU storage. So just what you said before, there just seems to be a total unlimited number of opportunities for Nvidia to sell their GPU technology, right?
Yeah, I mean, the point he made about the semantic storage, which goes back to what we just discussed in terms of what is a future enterprise system look like, right? That's more than storage, what he just announced. So I don't know if that means all the enterprise systems have to be completely rebuilt and redesigned based on that concept. has to be seen on the DGX and the announcement on the PCs. I mean, he's taking on Apple now, right? Because the leading data scientists nowadays use an Apple Mac. So I wonder how this works out. This will be interesting to see.
Yeah, no, two very big announcements. And look, I'd encourage everybody listening to go check out that full keynote. You kind of need to listen to it over a number of days, I found. But yeah, if you want to go listen to all about CUDA libraries and how that's the software to program GPUs, go check that out. It's phenomenal, but you do need to be I found as a layperson, you do need to be concentrating. Yeah, look, thanks very much, Thomas. That's really great. I hope that's been useful for the audience to review those kind of top 9 highlights, I guess, from Jensen's keynote there, that glimpse into the future. And anyone wants to get in touch with any questions, just ping them through on LinkedIn. And Thomas, as ever, thank you so much for coming on again, and look forward to seeing you on the next episode.
Thanks, Ben. Thanks for the invite again. I think we touched on the key points on that, but yes, you're right. Recommend everybody to go through the entire keynote, not only because it's highly informational, but just the videos itself is worth watching the keynote because it's so nicely done.
Yeah, indeed. A glimpse into the future. Right, let's wrap this up. Thomas, I shall see you soon. Thank you. You have a great day.
Thanks, Ben. Take care.
Cheers. Bye-bye. Bye-bye.